This was a problem from last time. We had blood pressure measured over 60 days because the claim is that you take a drug, a trial drug, and over a 60-day period, your blood pressure goes down, specifically speaking, the diastolic blood pressure goes down. So day 0, nothing was administered. Starting at day 1, we took the average of 10 randomly selected patients from some drug trial cohorts. And these are the measurements starting at day 1 up to 55, random days and random people. And it seems like there is a decrease in trend. Last time we did Spearman correlation. And what did that reveal? We concluded that there is a significant correlation . We're talking about a linear correlation, so let's be specific. And what was the estimate for rho? It was negative 0.887. 8865. So close.
Maybe it's a rounding issue.
Yeah, maybe it's a rounding issue. So, love that sarcasm. Negative 0.8857. So, good amount of correlation. Now we want to do field test. What is the objective of Theil? Well, Theil test is done for a different purpose, but closely related to the objective in the last problem. Suppose we have a linear model, y equals alpha plus beta times x. Alpha is the intercept, beta is the slope. If y and x are related, statistically, beta will not be 0. It doesn't matter whether it is positive correlation, negative correlation, doesn't matter, but beta cannot be 0. So the null is beta equals 0. The alternative, beta not equal to 0. Yes? What do we expect to happen? I expect to reject the null with the Theil test. We'll see if that happens. The procedure for Theil test is related to Kendall, not Spearman. And there is a strong requirement for Theil, which is we've got to sort the data for the x variable in increasing order. So x in our case is simply day of measurement, and y is the diastole. So as you increase the day, the diastolic pressure goes down, and we want x to be sorted in ascending order. Luckily, or intentionally, created the problem in a way that x's are in order, so we don't have to sort. Good? Yes, no way. What is the Theil statistic? The Theil statistic is C di is the difference. Now, what is di? Di simply is the ith y value minus alpha minus beta times xi. Now, since having the intercept doesn't even matter, because no matter what the value of alpha is, it always gets cancelled when we do the difference. So we can ignore the alpha and write it as di equals beta times xi plus yi. Under the null, if the null has any credibility, beta will be 0. Do we agree? So the difference is simply yi minus whatever hypothetically you will get from that model, alpha plus beta xi. Alpha will get cancelled anytime you do the difference di minus dj, which is what we're going to do. So there is no need for us to carry this alpha. So I drop that alpha, and I simply have yi minus beta times xi. Under the null, though, di is just 1. So pretty much we are finding the differences between the yi values. Good. Pairwise. So how many observations do we have? We have 6 observations. And di is just yi. And we have the x values in order. So how many pairs would we end up having? 6 observations. 15. We just have to compare, get the difference, dj minus or di minus dj. We'll do dj minus di, so 2 minus 1, 3 minus 1, and so forth. X2 minus x, y2 minus y1, y3 minus y1, and so forth. If that difference is negative, we put -1, positive, we put +1. Let's go ahead and fill this up. It would just be, up a triangle. So we simply have to look at the differences. So 94 minus 105 will give me -1, 99 minus 105, -1, 87 minus 105, -1 in terms of the sign excluding value. I'm just picking the sign. So 92 minus 105 will result in a negative number. So -1, same for the next. Good. Moving on, 2 and 3. 99 minus 94 positive. 87 will result in a negative number. Next one will be a negative number. Last one will be a negative number. And 3, the next 3 and 4. 87 minus 99, negative number. 92 minus 99, negative number. 76 minus 99, negative number. 4 and 5, 92 minus 87, positive number. 76 minus 81, negative number. Last one, negative. Good. If you add them all together, you will get C to be negative 11. Yes. C bar would be negative 11 over the total number of paths, which is 15. What do we get? Negative 0.733. Yes. How do we come to a conclusion when it comes to Theil? Theil sort of has its basics in Kendall. So I have the Kendall table of critical values. If you observe, if I pick an alpha of 0.05, erase. This is a two-tailed test, yes? Beta equals 0 against the alternative beta not equal to 0.
But if we want to use the same example from Monday, it would be a left tail test. Because the claim on Monday was at the crease.
That's what I was saying.
Right. So the claim on Monday was we were doing or trying to see if it is a negative correlation. Here, I'm trying to see if beta will be 0 or not. But wait for one more step. I'm not done yet. So I'm going to go in that direction. So give me a few minutes or seconds. So alpha equals 0.05, two-tailed test. 0 would be right in the middle. So you will divide by 2, 0.025 on one side, 0.025 on the other side. So the critical value is 0.867. This side minus 0.867. Yes. And I would simply end up saying, well, beta, C bar falls right here. So do not reject love, correct? Now, this is where, a bit of common sense, a bit of, visual exploration should come into play in practice. Last time we plotted this. Fine. So I have the data already. So day diet. So you have data of that sort, and it would be sort of not reasonable or irrational for me to test, could beta be positive or negative? Do you agree? Yes? If the line is strictly going down, why would I bother what's going to happen on the positive side? With me? So even though by standard definition, Theil is testing for beta equals 0 against beta not equal to 0, reasonable thing to do in our case beta equals 0 against the alternative beta is going to be less than 0. In other words, negative. Yes?
Yeah, but it makes it seem like you're leaving it to your discretion, but we're just doing that because that's what the prompt said.
I'm making it, okay, so I'm doing it in a way as to what you will do in practice. Right, in practice, you see a data set of this sort. And you start with the two-tailed test, like we've been doing, beta equals 0 against beta not equal to 0. And then you get a plot, and it looks like that. At that time, you have to stop and ask yourself, well, would that be reasonable for that data set? No, the appropriate one will be this. Does that make sense?
Yeah, that makes sense. But I mean, like, if a test said, test for a difference or test for correlation, you would go to the test.
Yes.
Even if it looked like that.
If the test problem said test for correlation, even if it looked like that, we would do a two-tail test. Right?
Could it exemplify which one?
I will specify. So the reason why I started with this is because of that from last time, right? We've got to think, well, sure, I did Spearman's rule last time, ended up giving us negative 0.886. Strong correlation, strong negative correlation. If you have strong negative correlation, one would expect this beta to be not equal to 0. Yes, negative or positive. But when you look at the graph, you see it's strictly decreasing, so the slope has to be negative. So the appropriate test would be beta less than 0. Good. If you look at the two-tailed version, you would simply say there is no correlation at all. And that will contradict what Spearman told us. Yes?
But when we change it to the beta correlation, we have to change variable value, right?
Yes, I'm not done. Headed that way, yeah. So the appropriate test based on the data would be left tail. Use the same alpha, 0.05. The reason why I'm doing this is I look at the plot and say, oh, beta has to be negative. Which is why in statistics 2023, when you did regression, they would start with a scatter plot always, right? That is your first step to see what the data looks like, and then you go from there. Going back to Kendall, 0.05, upper critical value is 0.733. Yes. In this case, it has to be negative 0.733. What a conundrum we are in.
So the thing
So we know the
you reject.
This value and that value ended up being one and the same. Yes.
Now that if you're round, you're rejecting. If you don't round.
I just want to know what you do.
So when you do the table with the negatives, negative ones, positive ones, in this example, you just did the subtraction exactly like Kendall because we didn't have a intercept at the end. Because the other examples you had us do like minus, like in the,
Intercept.
yeah,
Yeah, I think we mentioned, I don't know when you came in, but earlier I mentioned that this alpha will get cancelled. Regardless, when you do dj minus di, the intercept will get cancelled at each step. So whether it's there or not doesn't make a difference. So you can just drop it.
oh, okay.
So if you recall, we reject the null if the test statistic or C bar is less than or equal to the critical value. Right? Forget about rounding. Right? Doesn't matter. C bar is less than always less than or equal to So is it less than or equal to? It's not less than, it is equal to. So we reject null. Enough evidence to support beta is less than 0. If you recall correctly, on Monday, Chris was very hesitant. Man, I can't believe this, right? Even though we rejected, even though the drug seemed to be significant, I asked him, and he said, I don't think so. I asked him, would you buy into this? He said, no. And I asked him why. He said, too close, right? Same. In this case, it's not too close. It's exactly the same. So in a problem like this, we have to investigate further. This is the exact same conclusion we had last time. Even though we said there is negative correlation, our conclusion was we need further investigation because it's too close. And oftentimes, when a left-tailed test ends up contradicting with a two-tailed test, or a right-tailed test ends up contradicting the results of a two-tailed test, then it's a borderline scenario. You should always do further investigation. Here, we do have a contradiction. Does that make sense? Erase. The large sample approximation would use C, assuming LSA holds. The standardized test statistic is C minus mu over sigma. Mu is 0. What is sigma? Well, sigma squared. Where does it come from?
N minus 1. 2x plus
Over 18. That comes from Kendall. And of course, we've got a square root. That is how much?
I like the square root of 4. Sigma squared is 28.33.
28.33. So sigma would be 5.3.
Actually, 5.32.
So here, C was negative 13 divided by 5.32.
It's negative 11.
Oh, negative 11 divided by 5.32. What do we get? Negative 2.07. Yes. Again, based on what we told, we shouldn't be doing a two-tailed test. It has to be a left-tailed test. The area is 0.05. Yes. How do we find that critical value for the large sample approximation? Use the calculator, inverse norm. And what do we get? Negative 1.645. Negative 2.07. It's right there. Do we reject the null? Yes. The conclusion is to reject the null. Now, if I had used 0.025, then the critical value would have been negative 1.96. That would be a borderline case. It's slightly over negative 1.4, under negative 1.96. Does that make sense? Either way, this entire problem is a borderline case. We need a further investigation or more data. How do we find the p-value? Normal CTF, it is the area below the test statistic because we are doing left tail test. So normal CTF, negative E99, negative 2.07, 0, and 1. What did we get? 0.021? 19. Definitely less than alpha. Same conclusion, reject null. The drug is effective in reducing diastolic blood pressure, but we do have to keep in mind that this requires further investigation. Good. Now, okay, so last time we did Theil, we'll do Theil again. So day, dia type is left tail, so I'm going to put L and slopes equals true. On an exam, I'm not going to ask you to compute the slopes because you have to compute 15 different slopes. But if I decide, I'll give you the slopes. Once we have the slopes, that is our line. Those are the slopes for the 15 parts. We can simply find the estimate for beta by computing the median of those values. Why median? Because this is a non-parametric test. So we have the beta value. Beta, the estimated beta, is negative 0.429. So it is given that beta hat is negative 0.429. And we want to find alpha hat. Yes?
So would this be a simple example?
Yes. I'm never going to ask you to compute that slopes table. No. I will start with either giving you the slope values or just make it easy on myself and give you beta. Right? So I showed you last time how to do this using the calculator. Since we have beta hat, yi minus beta hat xi would give me alpha hat I. Correct? And we used the calculator last time. So
So the
the beta hat value is obtained from the median of all the slopes we computed using the past. I'm not going to ask you to do this in class because I want to compute 15 different slopes using y2 minus y1 over x2 minus x1. We don't have time for that. I'll give you that. We have to find alphas. So for each y observation and x observation, we can plug in that beta and solve for the corresponding alpha hat. You take the median of all those alpha hats, you will get one alpha hat, and that should be our estimator. Good? So that is our model. Next time, we're going to start with this, wrap it up with a confidence interval. Sounds good? Okay,
Professor, can you draw the line?
sure, why not? Why does it not matter?
Oh, no, I just want to see.
It will, it should.
No, I don't doubt that it will.
No, it doesn't.
No, it doesn't. And guess why it doesn't? Because of rounding.
Oh, yep, that too.
Anything goes wrong, we'll simply blame it on
I'll just
rounding.
be like, well, if you rounded differently, I would have done it different.
Or, as engineers would say, it is heuristic. So I have the x values, the y values computed using the model minus 0.429 times x plus 102.65. So plot, no, I already have the plot. So lines x comma y color equals tomato, and
Oh, I can take it back.
you. That is the line. Sounds good. So the line that the program gives us
Same as the slope.
right, that is the one that we got from the test. Little bit of rounding, and if you
It's the same.
you get the same line, right? Because it is the same.
Because it's in R, there's no rounding.